So to this session, I'm going to deliver about overview of TCP/IP. So the TCP/IP, I hope you all studied in the previous topics. So, but here, specifically, I'm gonna discuss about how this TCP/IP is adopted for mobile computing. So when you talk about TCP/IP, so why this TCP/IP? TCP/IP is more reliable, fully duplex, and then it is a connection-oriented protocol. So it streams delivery. So interface presence to the application doesn't require data in an individual package. So this data is guaranteed to arrive and in the correct order without duplication. So that is one of the key aspects of this TCP. So imposes significant overhead. So these are all the basic things that we already know about TCP. So the main focus of this particular topic is we're gonna discuss about the TCP/IP protocol suite. The TCP/IP model explains how the protocol suites work to provide communication in four layers. One is application layer, transport layer, inter-network layer, and network interface. So the TCP has an request to commence. So it has a define, describe, standardize, implementation, configuration of this particular TCP IP protocol. When you see this diagram, the left side, it completely deals with TCP IP. And the right side is what an OSI model. So what are the difference with this TCP IP with respect to OSI model is the data link layer and the physical layer or together we call it as a network interface, and then transport network together, we are not like distributing. The network is what inter-network, and transport is same as transport, but top to that transport layer, all the layer put together we are calling it as an application layer. So that is a session, presentation, and application together we call it as an application layer. So in the TCP/IP architecture, as we said, starting from data link to the application layer. So what are the different protocols responsible for it? So first we will see about the application, presentation, session layer. Together we call it as an application layer. The TCP will take a responsibility about most of the applications which is used on this particular layer. For example, let us consider that using an FTP, file transfer protocol. So the entire protocol which flows from top to bottom with respect to an application layer. Like that, voice, telnet, SMTP, DNS, SNMP, DHCP, RIP. All these are all the applications, example applications which is running on top of on the application layer. The application layer, applications like protocols like file transfer, FTP, as I said in the previous slide. So these are all the protocols which is run on top on the application layer. The next is the transport layer, where RTP, real-time protocol, real-time transmission protocol, transmission control protocol, user datagram protocol, optical based protocol, all the protocols, right, are considered with the transport layer. So when you go for this transport layer performs end-to-end packet delivery, reliability, and then flow control. These are the three parameters that this particular transport layer is in charge of. So the protocols which is not directly involved with transport layer, which provides TCP reliability, connection-oriented communication between two hosts, requires more network overheads. When we are using an UDP, which provides a connectionless datagram services between two hosts, always it is fast, reliable. So the reliability fast but less reliable. Reliability is left to the application layer. The ports which is used in the transport layer, whether it is in TCP or a UDP, port numbers for the communication between the hosts. So there are there are three ranges of the ports. One is well-known ports, registered ports, and dynamic and private ports. So these well-known ports are from 1 to 1023. The registered ports are from 1024 to 4915, and then dynamic ports are 49152 to 6535. So an example between the FTP client and the server model. So where which is using an FTP communication with TCP process. So where you have these layers where network interface, internet transport and application. So how these ports are used in the FTP, where the TCP port transport layer, which is which is used, the transmission client uses 1029 and 1030, whereas the server used 21 and 20. Using these ports, the client will communicate to the server and the server will communicate to the client. This is an example how the ports are used. So TCP uses three-way handshake model. So where it established reliable connection between 2 points. So TCP transmits 3 packets before actual data occurs. Before two computers can communicate over TCP, they must be synchronized their initial sequence number. The rest packets indicates that TCP connection is to be terminated without interaction. As I said in the previous slide, so there are three ways of handshake. So let us assume that this is the host A and this is a host B. So now the initial state is that connection request. So the connection request, so where it uses 200 of ISN. Once the connection request packet received by the host will send back an acknowledgement with 201. This is an initial request and this is an acknowledgement, whereas the ISN is based on the packet, right? This is ISN from A and this is ISN from B. So with the 201, once the acknowledgement received by the host A, the host A will send back an acknowledgement with ISN plus 1 for an acknowledgement of 201, right? So once the acknowledgement is received, then the data will be transferred from the host to the destination. That means here the host A to host B. So these three steps we call it as a three-way handshake. So this is how the three-way handshake connection establishment is happening. So same like host A and host B. So as we said about initially the connection request is happening by is initiated by host A to host B, and then if there is no acknowledgement, then the host A will just send a duplicate packet again. So once it receives the duplicate packet, the host B will send an acknowledgement for the packet, the second packet, because this is 60 and this is 61. So but for the 70, the B doesn't receive anything, and once it is done, then the host will send back and reset information, because the previous packet 70 request has not been received and acknowledgement not been received, so it will give an reset information. Once the reset information is given, the host B will send back an acknowledgement of 71, because this is a previous acknowledgement. So once this previous acknowledgement is sent, then again the host A will send back an acknowledgement for 71. So this is how a connection establishment done, and the miscommunication has been completely eradicated using a TCP/IP. So in the TCP/IP architecture, so we will see the network layer. So before a couple of slides, we have just seen application, presentation, and session layer. We have seen about the FTP, and then in the transport layer we saw about how UDP and TCP are utilized to transport the data. So now in the network layer, so we will see the network layer lies between the transport and the data link layer. So where so this data and the transport layer, so where this is taken full responsible about finding the right place or destinations, and then transferring the data packet. So the network layer plays same as the data link layer, and then physical layer of OSI model. And mainly it utilize the MAC address, so network card drivers and specific interfaces for the network card function at this level. So no specific IT function exists at this layer. And then because the layer focused on communication with the network card and other networking hardware. So that is the main responsible of this particular network layer. So in the network layer, it has the four main protocols. One is Internet Protocol, and then Internet Control Message Protocol (ICMP), and then ARP Address Resolution Protocol, and Reverse Address Resolution Protocol. These are all the primary protocols which is used in this particular layer to transfer the information. So the ARP, just let me explain a basic concept about the ARP. So ARP mainly used for routing protocol. So it is otherwise called as, it is also a routing protocol. What the main thing it will do is, it is having a table where this table are mapped to the concerned IP address and the MAC address. Whenever the data is requested, or whenever the source want to transmit to the destination, then the ARP protocol will look the table which is containing MAC address and IP address of the other devices or the equipment in the network. So that based on that, the data will be transmitted. So it checks for ARP cache for the IP to the MAC address mapping for its destination address. So this is one example where I just showed you a demo. So where if the source computer, the point is that, so here I have used this particular IP address to check the table, MAC table of this one. So here you can see that this is the address, IP address, and he have the physical address and what type of physical address is this. So when I just ping the 192.168.10.2255, then automatically it will check for this particular physical address and try to communicate with it. So this is called as IP host ARP table. So by this end, I am winding up this particular session. So we will looking forward a few other topics under this mobile computing platform. Thank you. Have a great day.